The story of our solar system begins 4.6 billion years ago within a swirling nebula of gas. Vast clouds of interstellar dust drifted through the void, where gravity acted as the ultimate cosmic sculptor. As the sun ignited at the center, a thermal gradient dictated the destiny of every forming world. Near the scorching heat of the newborn star, only metals and rocks could solidify into dense matter. This intense heat gave birth to the terrestrial planets, forging them from the remnants of the nebula. Mercury emerged first as a dense, iron-rich sphere, scorched by its proximity to the blazing solar furnace. Venus, Earth, and Mars developed rocky crusts and distinct geological personalities through eons of slow, steady accretion. Venus became a volcanic furnace, trapped forever in the suffocating grip of a runaway greenhouse effect. Its atmosphere thickened into a toxic shroud, hiding a landscape of tortured rock and endless, searing heat. Earth evolved into a vibrant oasis, blessed with liquid oceans and a life-sustaining protective blue atmosphere. Mars transformed into a rust-colored desert, hiding frozen water deep beneath its desolate and cratered surface. These inner worlds represent the solid foundations of our cosmic neighborhood, standing firm against the dark. Each planet was shaped by its proximity to the sun and the violent, chaotic collisions of youth. The early solar system was a place of constant motion, where debris rained down upon forming worlds. Protoplanets collided in massive, fiery impacts, reshaping the very geography of these nascent, rocky, inner spheres. Gravity pulled the heaviest elements toward the center, while lighter gases were pushed outward by solar winds. The sun grew stronger, its radiation clearing the remaining dust and gas from the inner orbital paths. Mercury remained a scarred, metal-heavy sentinel, its surface a testament to the harshness of the inner system. Venus continued to churn with volcanic fury, its internal heat unable to escape the thick, heavy clouds. Earth found a delicate balance, its magnetic field shielding the atmosphere from the relentless solar particle stream. Life began to stir in the ancient, cooling oceans, a miracle born from the chaos of formation. Mars, once perhaps warmer and wetter, slowly lost its atmosphere to the cold, unforgiving vacuum of space. Its rivers dried into winding channels, leaving behind a silent, red monument to a lost, watery past. These four worlds, so different in their current states, share a common origin in the swirling nebula. They are the children of the sun, forged in the same crucible of heat, gravity, and time. The inner solar system remains a record of the violent processes that defined our early cosmic home. Every crater on Mercury tells a story of an impact from the era of late heavy bombardment. Every mountain on Earth reflects the tectonic forces that have shifted continents over billions of long years. The solar system was not built in a day, but through a slow, grinding process of evolution. Gravity acted as the architect, pulling together the scattered dust into the complex structures we see today. The sun served as the engine, providing the energy that fueled the differentiation of these rocky worlds. Without the thermal gradient, the planets might have been uniform, lacking the diversity that defines our system. Instead, we have a spectrum of worlds, each with its own unique history and physical-chemical composition. The terrestrial planets are the bedrock of our understanding of how rocky worlds form around distant stars. They demonstrate that the process of planetary formation is both universal and deeply sensitive to initial conditions. Distance from the host star is the primary variable that determines the fate of a rocky planet. Too close, and the atmosphere boils away. Too far, and the world freezes into a barren wasteland. Earth sits in the narrow golden band where conditions are just right for liquid water to persist. This perfect placement allowed for the development of the complex chemistry that eventually led to biological life. The inner solar system is a laboratory of planetary evolution, offering insights into our own fragile existence. We look at Venus and see a warning of what happens when a greenhouse effect goes unchecked. We look at Mars and see the potential for a world to lose its ability to support. The history of these worlds is etched into their very surfaces, waiting for us to read them. Space probes and landers have begun to scratch the surface, revealing the secrets hidden for billions of years. The metallic core of Mercury, the thick clouds of Venus, and the red dust of Mars beckon. They remind us that we are part of a larger, dynamic system that is constantly changing and evolving. The inner planets are the first chapter in the grand story of our neighborhood in the galaxy. They are the solid, tangible evidence of the cosmic forces that shape the architecture of our system, As we study them, we gain a deeper appreciation for the unique conditions that allowed us here. The nebula that birthed the sun also gave us these rocky companions, bound by gravity and light. Their formation was a symphony of destruction and creation, a dance of matter in the dark void. The terrestrial worlds stand as silent witnesses to the birth of our solar system long ago today. They remain the most accessible targets for our exploration as we venture out into the great unknown. Every mission to these worlds brings us closer to understanding the origins of our own home planet. The inner solar system is a testament to the power of gravity and the persistence of life. It is a neighborhood defined by its rocky foundations and the enduring influence of the central star. We are the observers of this cosmic drama, piecing together the events of 4 billion years ago. The story of our solar system is still being written by the ongoing processes of planetary change. From the molten beginnings to the present day, the inner worlds have remained our closest cosmic neighbors. Their existence is the foundation upon which all our knowledge of the wider universe is built today. Beyond the asteroid belt, the rules of planetary construction shift dramatically as we encounter the gas giants. Jupiter and Saturn, composed primarily of hydrogen and helium, grew into massive spheres without any solid surfaces. These giants are dominated by crushing pressures and metallic interiors that defy our understanding of solid matter. Further out, Uranus and Neptune exist as ice giants, where water, ammonia, and methane freeze solid. These compounds exist in exotic states under extreme gravity, potentially even raining diamonds into their dark depths. These mysterious, cold regions hold secrets about the early formation of our complex and diverse solar system. These outer giants serve as a testament to the vast diversity found within our own cosmic neighborhood. They prove that the same cosmic ingredients can produce wildly different outcomes based on distance and mass. As we gaze toward the hundreds of billions of other stars in our galaxy, we feel small. We realize that our own planetary family is merely one variation of an infinite, complex cosmic recipe. This realization leaves us to wonder what other extraordinary worlds await discovery in the vast, unexplored reaches. The universe stretches out before us, a canvas painted with the light of countless distant, burning stars. Each star potentially hosts its own family of worlds, shaped by the same fundamental laws of physics. We are observers of a grand design, tracing the history of matter from dust to complex life. The journey of discovery continues as we peer through telescopes into the deep, dark, and silent void. Every point of light represents a potential story, a history written in the language of gravity, motion. The gas giants stand as sentinels, guarding the outer reaches of our sun's immense and powerful influence. Their swirling storms and intricate rings tell tales of a violent, chaotic, and truly magnificent cosmic birth. We look back at our own blue home, appreciating the delicate balance that allows for our existence. The solar system is a masterpiece of orbital mechanics, a clockwork engine running for billions of years. From the inner rocky worlds to the outer icy giants, every planet plays a role in balance. Gravity continues to pull, to shape, and to influence the dance of these celestial bodies in space. We are the architects of our own understanding, building models from the data gathered by our probes. The future of exploration promises to reveal even more about the nature of these distant giant worlds. Perhaps one day, humanity will venture beyond the asteroid belt to witness these wonders with our eyes. Until then, we rely on the light traveling across the vast distances to tell us their stories. The ice giants remain elusive, shrouded in thick atmospheres that hide their true, cold, and dark nature. Neptune's winds whip across its surface at supersonic speeds, creating a dynamic and ever-changing weather pattern system. Uranus tilts on its side, a strange anomaly that challenges our theories about early planetary collision events. These quirks make our solar system a unique laboratory for studying the evolution of planetary bodies everywhere. We are part of a larger narrative, a cosmic story that began long before our ancestors appeared. The dust that formed the planets also formed the atoms within our own bodies and our minds. We are made of star stuff, connected to the very giants that drift in the outer darkness. This connection gives us a sense of belonging in a universe that often feels cold and indifferent. As we contemplate the scale of the cosmos, we find beauty in the precision of the orbits. The gas giants act as shields, protecting the inner solar system from the constant threat of comets. Their massive gravity wells redirect incoming debris, keeping the inner neighborhood safe for life to potentially thrive. We owe a debt of gratitude to these massive, swirling, and gaseous titans of our cosmic home. They are the silent guardians of our fragile oasis, ensuring the stability of our long-term orbital path. The study of these worlds is not just about science, but about understanding our place in time. We look forward with hope, knowing that the mysteries of the universe are meant to be solved. Every discovery brings us closer to answering the fundamental questions about life, existence, and our origin. The outer reaches are calling, inviting us to explore the unknown and push the boundaries of knowledge. The story of our solar system is far from over. It is a living, breathing, evolving process. We are the witnesses, the chroniclers and the dreamers who look up at the night sky tonight. The giants wait in the dark, silent and majestic, holding the secrets of our deep, ancient past. We will continue to reach out, to learn, and to grow as a species among the stars. The cosmic neighborhood is vast, but it is also our home, a place of wonder and discovery. Let us cherish the knowledge we have gained and remain curious about the wonders yet to come. The light of the sun reaches even the furthest planets, connecting them all in a single system. We are bound by gravity, by history, and by the shared destiny of our small, bright star. The journey through the solar system is a reminder of how much there is left to explore. Every planet, every moon, and every ring particle has a unique and important story to tell us. We listen with our instruments, our minds, and our hearts, seeking the truth in the deep void. The exploration of the outer giants has only just begun, and the future holds many new surprises. We stand on the threshold of a new era of discovery, ready to embrace the unknown depths. The universe is an infinite library, and we are just beginning to read the first few pages. May our curiosity drive us to seek answers and find our way among the distant, silent stars. The cosmic neighborhood is waiting, and we are ready to take the next step in our journey. Our story is the story of the universe, written in the stars and the planets above us. If you found this video as engaging, please subscribe to the planetarium.